About our compiler, I'm going to give you some starting code today, and then you're going to have your first homework assignment. Yeah. Well, your first programming assignment. So your first real homework assignment. All right. So if you remember from last time, we were reading in our source code file, which looks like this guy. My first program.simon currently looks like this. Well, that's from something I did earlier.
Are we recording yet?
We are recording. That was a pretty good one. I can't even repeat that on recording.
For fear of a lawsuit.
No, I mean, nothing that was said was bad. Just, if a geek were to interpret. Okay. So, if you remember from last time, we were reading in, using our file reader, reading things in one character at a time, right? And if it was right, we were printing out true or false whether or not it was white space. So here, just to make, well, we'll concatenate on a carriage return. So we should have a bunch of falses and one true for our white space. This is for the first 7 characters. So that would be 1, 2, 3, 4, 5 is white space. That's a carriage return. 6, 7. 1, 2, 3, 4, 5. So it's detecting our carriage returns as white space. Okay. Now, how do we know we're at the end of a file?
Stop being things.
Well,
Does input read return 0?
do 70.
Oh, isn't there like a certain amount of question marks?
If we put it into characters.
Yeah.
5, 4, 5.
Huh?
Oh, trillion. Trillion question marks.
Okay. So we got there to the end. We have one extra carriage return here, right? I took it out of there. We'll run this again. Okay. So now we're interested in what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We're interested in what 23 is, right?
What if you have a question mark at the end of your...
Those question marks aren't really question marks.
They just display.
That, yeah, it couldn't interpret the Unicode value. So I'm going to show you the actual integer values now. So I'll do carriage returns at the end of each one. So we'll just have each Unicode value per line. So our last Unicode value should be, actually I think our last 2 should be identical right now. Okay, so we get a -1. This is our last carriage return. That's the press enter at the end of that last line. And then we have a -1 when we can no longer read in stuff. Make sense? So keep going until we read in a -1. That is how we know we're at the end of the file. Go ahead.
So simply just input dot read if the negative if statement, but if it equals -1, it's done. That's the end of the...
Yeah. So if we want to rewrite our for loop here, we're going to say, actually, let's do, we'll say char c is equal to, screw this, int val is equal to input dot read while val is not equal to -1, we'll print out the char version of val. And then we'll read val in one more time. Okay, so this gets the ball rolling, and we really need to read it in once beforehand, and we can't necessarily do this inside of a do while because you might be dealing with an empty file right off the bat. So we'll read in the very first character. As long as it's not the end of the file, we'll print it out, the character version of it, and read in the next character. Do that over and over and over again. So this should now print out the total contents of our file, regardless of how much we add to our file.
Basically compiled already.
Okay, makes sense? So now we have something that's reading in one character at a time. Okay, well, we need to get tokens. We need to read in tokens. Exactly like Lord of the Rings. That was the example I was going to use. But all right, so we want to start off with something that looks like this. I have not, but I'm going to give myself a reminder. What time? 6 o'clock tonight, maybe? Remind me to watch Archer tonight at 6 p.m.
Here's your reminder. Okay, I'll remind you.
Hopefully I can stay awake. You got to cut me a little. If I go and do weird programming stuff, I've had like 3 hours of sleep in the last 4 days. My wife is like really sick. So I'm like up, like emptying puke buckets and stuff. So if I start writing, I mean, I'm sure I won't write as bad of a code as you guys do, but cut me a little slack because I'm operating on caffeine and Gatorade.
Do you like mix them together and just mix it? Do you just make like you just make it with Gatorade?
I was reading earlier the actor that died from the drug overdose. He was just in the Hunger Games movie, right?
Oh yeah, he died.
Yeah. And so they did the autopsy today. They haven't actually officially released the details of the autopsy. I guess they found him. He had a syringe in his arm. They found like 50 bags of heroin in his, and like, you know, basically it looked like he was running a pharmacy, like not a legit pharmacy, but a pharmacy out of his.
Which one? Which actor?
He played like the games maker in this last one.
Twister, he was
Yeah.
He's
So-
the game maker in the second.
I mean, at some point, somebody needs to do some like legitimate research into. Well, not just that. I mean, there's a correlation between high income positions and drug abuse because it's afforded to them. You know, they can afford to buy 50 bags of heroin. I mean, I don't know how much heroin costs, but I assume it's probably pricey. It's a supply and demand type thing. Well, I mean, hold on, but we're seeing some of the same things now with some of the child actors like Miley Cyrus and now more recently the Bieber, Justin Bieber guy. I mean, you know, society just destroys these people. You know, they're multi-zillionaires when they're 12, and I mean, think about the stuff that you did when you were 12. When I was 12, I think I was 12 or something like that. I jumped off the roof of my house thinking it was a good idea. And then like I landed on my feet, but like, you know, gravity forced me to like do like a power squat. I was never right after that. You know, and this guy's driving around a Lamborghini at 12. He's 16 now, isn't he? Bieber?
He's like 20.
Oh, is he? He's older?
He was like driving a Lamborghini, he was drinking, he was smoking weed, and he's on prescription drugs.
He was like, The pharmacy Lambo.
Yeah, so. But it's almost an argument for, maybe, I mean, I don't really think this is true, but like to some extent communism. Because when you have people making so much more money than some other people, they're the targets for the drugs. I'm not going to show up if I'm selling illegal drugs. I'm not going to show up to somebody who doesn't have any cash. I'm going to go to rich people because they're the ones with the disposable income to abuse my product. What's this? Well, wherever. I mean, the fact that they have so much money, they can do it. I mean, society is destroying these people because you have to assume that they're not all bad people. Somebody.
They shouldn't be allowed to have money unless they're smart.
Well, some politician not that long ago. No, actually, he was a professor here from Concordia, Jim Berkey. He was running for, was it Senate a couple years ago? Or House of Republicans? No, it was either Senate or the House of Representatives. But in any case, his idea was that nobody's incorruptible. Doesn't matter how altruistic you are when you go in, enough money or enough influence and everybody's corruptible for a price, I guess. Who knows? Okay, so in any case, I've gone ahead and I've updated my code to a single line. We're probably going to want to have a couple of different lines in ours. In fact, let's go ahead and do that. Well, I'm just going to add. I'm going to add some more.
Well, I had figured out how to edit. Now I can't.
Huh?
Just figure this out again.
Let's see. I need to come up with another formula. I need a second formula.
I don't know any formulas. Y equals mx plus b.
Y is equal to mx plus b.
Oh, nice one.
There's no
Like that?
Because you don't have enough sleep.
Okay. That'll be good enough for our example.
Do we have to separate M and X?
Well, no, mx is the name of the variable.
No, M times X.
Oh, is it?
Yeah.
That's not what you said. Oh, now I recognize the formula. So, it would be that. All right, so let's make sure it reads in those two lines. It does. Okay, so now, we need to accomplish, now, first of all, what your assignment's going to be. I'll go ahead and give you your assignment now. What your assignment due on Wednesday will be is to write the lexical analyzer. So take our input file and output something that looks like this. Okay? Huh?
We have to have like the ID.
Yep.
Do we have to,
We're going to write some tokens today.
do you have to count for multiple scopes?
No, because you're not interpreting it. Yeah, you're just replacing. And we haven't even defined our language. So we're doing this at a very basic step at this point. So let me go ahead. Shut up. Because it only benefits you if we accomplish more programming today, because I'm going to give you a starting point. Come on.
Oh, what the hell?
You think you're better than me?
End up with your fever dream code that won't help us at all.
Simon's.
Shorty. Well, you take a lot of classes.
Joey's on a roll today.
How many classes are you teaching?
I think 5. And then some online ones too. I don't pay attention.
I've noticed that.
Yeah, I don't know what last year's videos.
It's not how you spell analyzer.
Since 2005.
Well, no, that's not actually a fact. So,
Guys due on Wednesday.
seeing the inner workings. Oh, it's the
And do not forget to do the self-assessment, Dealey. For those of you who forgot to do it for your paper,
Wasn't me, don't
you haven't just turned your paper in yet. Okay, so shut up. So as we're going through here, we need to be able to read in each of these things as tokens so we can do something with them, right? So what I'm asking you to shut up. Okay, so what I'm asking you to do for your homework is to build the lexical analyzer that the book talks about here, where the output looks something like this. It's replaced position with something that says ID 1, replaced equals with the token that is equals, so on and so forth, okay? So in order to do this, we need to be able to read in from our source code file one token at a time and skip white space, right? Okay, so in order to do this, we need to write some code that allows us to get tokens. And we're going to write this in an object-oriented manner because that's what makes the most sense, right? Good. So we're going to create a new class called source reader. Our new class is going to have the input and import java.io.file reader in it. So we're going to take all this code that we have so far and we're going to bring it into our new class. So we're going to have a private field of type file reader. Then we're going to have a private string called path. All right, and we'll have our public source reader. It's going to take in a string path. So when we create a source reader, we have to pass it the path of our source code file. We'll say this dot path is equal to path. And then we'll actually create our file reader. So input is going to be a new one of these guys. Except we'll pass it path. Okay, and this guy potentially throws an exception. So we'll go ahead and do try this, catch, file not found exception. We have to import that file not found exception up there. So if we have a problem, we'll do system error println that prints it out to the error stream. So what's our, huh? we can do that. Okay. So when we build our source reader, we're going to send it in a path, set our string field path equal to that path. Then we'll try to build our file reader, and if it works, we will have it built. Otherwise, we'll catch the exception and the program crashes. Okay? Next, I'm going to grab all this code. I'll just quickly write a public void read method. Put all that stuff in there. And we'll try to do all this. Catch the IO exception E. We need to import the IO exception. Okay. So that's what our source reader looks like right now. Now to make sure everything's working, we're going to go into driver. We'll create our new source reader, passing it the source of our file. And then we'll say source.read, and hopefully we get the same output we had before. Okay, so we encapsulated our syntax reader, the thing that's reading in from our file, inside this thing called source reader. So all those details are in there. All right, now the reality is when we read, we're going to go ahead and rename this guy to read tokens. Okay? And we're probably going to ultimately make this private, but for right now we're going to have it be public so we can test it from the driver. So what does read tokens do? Read tokens should read things in one token at a time and display the entire token to the screen. Does that make sense? So I'm going to create a method here, private string get token. Get token's job, read the next token from the file reader. That's what that method's job is going to be. Okay? It already has access to the file reader up here. It's called input. Now, what is a token? If you had to define what a token is, what would you say?
Chunk code.
Okay, that's a decent starting point, just because you know that I like the word chunk. Okay, it is a chunk of code.
String of characters between two white spaces.
A string of characters between white space, not necessarily two white space, but yeah, between white space. So that means in order to read a token, we ignore white space until we start reading non-white spaces. Then we capture characters until we finally read a white space. What's our token? The dude left over. Make sense? All right. So we'll create a string called the token that we're going to build our token up into. We'll go ahead and try. Okay, so we'll go ahead and we'll read in val. we're at the end of the file. Right off the bat. We're out of tokens. Is that a correct statement? Okay. We just tried to read something in. If we're at the end of the file, we are out of tokens. Now, does that mean that we have one of two things is true? We either just read in our last token, or we previously had read in, or this is our last token. We either previously read in our last token, or we're in the middle of building our last token, finally read in end of file. Does that make sense? All right. So we'll read in a val while character dot is white space char version of val. So while that's true, what do we want to do? If we're reading in white space, what do we want to do?
Skip.
We want to skip it. Okay? And what does it mean to skip it?
Return. Go to the college or something.
Read the next one, right? So what does this guy do? This guy skips through leading white space. There might not be any leading white space. We might be right at the beginning of our first token. Okay, but this will jump past any leading white space. So what this takes care of is situations like this. Wasted space, correct?
Is having a different character, or is it just a bunch of spaces that get put down at once?
Tabbing would be a different character. \tab. It'll be a Unicode character. Yeah.
It's not just white space then for that method.
Huh?
Or that method.
I think it'll treat it as white space. Go ahead.
How did you exit and save in BI again?
Press escape.
Yeah.
Colon. WQ. All right, so we'll skip the leading white space. So when we get right here, we know that val, whatever's in val, is our first non-white space character. Correct? And what do we want to do with that? We want to say the token plus equals the char version of val. Concatenated onto the token. So we're building up our token. And then we're going to steal most of that code again. Read in the next val. While we are not looking at white space, the token plus equals char version of val, and then read in the next character. So this says what? It says burn past all leading white space. So ignore, ignore, ignore. Finally found a real character. Okay. Now, as long as I'm looking at real characters, keep tacking it onto my token until I finally hit something that is white space. Once I finally hit something that's white space, all this stuff right here should be stored inside of the token. And what do we want to do? We want to return the token. Go ahead.
Would you redefine val again with the input read? Because if if it is not a white space, then you're calling the next character again.
Yeah, but I already stored it here.
Oh, right, okay.
So I put it into our token, and then I don't need it anymore
So
after
it's
that.
immediately going to the next one.
Yep. So skip past all leading white space until Val finally is pointing to a real character. Store that real character as the first character of your token. Then read in the next character. I mean, remember, you might have a variable name that's one character long. So remember, while loops are pre-check loops. There's no guarantee we'll ever enter this loop. So as long as Val is not white space, that means it's a real character, tack it onto our token and read in the next Val. Keep doing that until we finally hit white space. Once we finally hit white space, we're done with our token. Return. That makes sense? A couple things we need to check here. We need to figure out whether or not the end of the file is treated as white space. Okay? So I want to do this. I'm going to return null inside the catch. So if for some reason something bad happens, we'll just return a null token. Okay, that's what get token will do for right now. Okay. And actually, I'll go ahead and put the token inside the try. Didn't really make a difference, but I'll just move it in there. So now, before we go any farther here, let's go back down to our the code we're reading. Let me indent this real quick. Okay. So we're going to print out the character. We'll do this for Joey. Followed by a tab. Followed by the integer. Followed by a tab. Followed by character dot is white space char version of val.
You're gonna need some quotes around those.
Okay. So I'm going to print out our actual character, followed by a tab, followed by the Unicode value of that character, followed by a tab, followed by whether or not it's white space. Okay? And actually, let me do this. I'll put the character version of it out last because in a character return situation, it would kick it down a line. I'll go ahead and manually kick it down a line, so we'll just get an extra line at the end of a sentence. Okay? And then we'll go ahead and look at read tokens out here in driver. Because what we want to see is we want to see how does it treat the end of a file. Okay, position equals, there's our true, at the end of that line, or for our white space, equals initial plus rate. Here's our 10. Then this was a enter, so this is a character return, that's why we have the extra line. Okay, then we read in the second function. Here's the end of that one where we pressed enter. Now we're never actually reading in the -1. Why not? Go back to my code here. So there is not a carriage return here, right? At the end. There's no carriage return. So there's my 10. What if I put in a carriage return? So I'm getting the 10 again. So I'm treating these as white space. Everything we're reading in is white space. And why is that? If we go back to our source reader and we look at read tokens, what does this guy do? As long as whatever it just read in is not a -1, then print it out. Okay, but we might have a little bit of an issue that we might have to get over. Right now we're reading things in one character at a time. But as I read in one character, what I actually want to do is I want to get a token. I want to display the token. So I'm going to get rid of this crap. I'm going to say system.out.println this.get token. That should read in a token, right? That's what I do as long as val is not equal to -1. Wait a minute. What do I do now? Well, let's back up. I'm going to get rid of all this. Cur token is going to be equal to this dot get token. So we'll try to read in a token. While cur token is not equal to null. Actually, we could probably do this in a do while. So we'll read in a token, display that token, and we're going to keep doing that while cur token is not equal to null. And this guy doesn't throw an exception, so we don't need to wrap it in our try catch. So we'll create a variable for our cur token. We'll read in what we hope is the very first token. Could be null. We might have an empty file. Then print out the token. Keep doing that over and over again until we finally read in a null token. So now what we're interested in is whether or not our read tokens successfully calls get tokens a number of times that we get all of our individual tokens. And if we get our individual tokens, what should we see? We should see position, followed by equals, followed by initial, followed by plus, followed by rate, followed by time, followed by 60, followed by y, equal m times x plus b. Position equals initial plus rate times 60y equals m times x plus b. So we write in all our tokens? Okay. Well, now let's try to throw some curveballs at this. Will this still work?
Yeah. Hope so. Wait.
Okay, still worked. Will that work?
Yeah.
There's no way we could have a break at you.
Now, of interest here, okay, it's not reading any empty tokens. So it looks like we're pretty good there. I just printed out the length of our tokens. Okay. So this guy appears to be reading in all of our individual tokens, correct? For our lexical analyzer, what do we need to do? We need to take each of those tokens and we need to rewrite it into a generic token, if you will, where a generic token is surrounded by less than and greater than signs. But we also need to store each of those identifiers somewhere. So that means we need to have a collection somewhere of allowed symbols, that is, non-identifier symbols. What is that collection? Well, we know we have equals, plus, times. We can probably just assume all the numeric types, right? All the, all the equal signs, operators, those guys. We can assume all the operators. So I'm going to need to create somewhere private, let's call this guy, we'll make him a string array, reserved words. Okay. And then inside here, we're going to say reserved words is equal to, well, we know equals is a reserved word. I'll just do it all one big line. We know that plus is a reserved word. We know that minus, times, divide. We don't have one in there, but we can assume they are, right? Okay, so right now we have a language that deals with math. So we'll say those are all of our reserved words, correct? Oh. Oh, so it wants it to be all on one line. Yeah, see if I do this, if I say string array, reserve words equals that, it's fine with it. It doesn't like me to define it in multiple lines. Huh? No, I just tried to define the variable up here that, well, I do in this case. But there's a shorthand that you could do it this way. But I need it defined up here. Go ahead.
Like a double slash, so it's slash. No.
No, because it's inside of a string. Because, like, I mean, this slash isn't a It's not a placeholder for anything. So that should be fine. So then what we really need to do here, just for the sake of the assignment, is we'll say reserve words 1, 2, 3, 4, 5 equals new string array 5, and we'll say reserved words at bucket 0 is equal to equal sign. One, two, three, 4. Later on, we'll probably have a table that's going to have our reserved words in it. So a file that might have our reserved words in it. Yeah.
Because you put like string array there, isn't that redeclaring it instead of actually?
Yeah, I don't need the string array now because I defined it up here.
Oh,
We're good? All right, so these are all of our reserved words. So our current language is what? It's a language containing identifiers, reserved words like this, and one other type. That is, tokens that begin with a number are considered to be literals. For right now, we can assume our syntax is perfect. Okay, because we're not at the point where we're checking syntax. But that means that any token that begins with a number, a hard-coded number, is a numeric literal. So it should be treated like this. Don't throw it in the table. That makes sense? So for your assignment, all identifiers must be stored in a I'll make it easy for this one. We're going to put them in an array called identifiers, or symbol array. Must be stored in an array of symbols. Reserved words are equal, plus, minus, times, divide. Constants are any identifier starting with a number. Make sense? And as a starting point, I'll give you our source reader file, this guy. I'm not going to give you our driver file because it has 3 lines in it. You guys should know how to build that. All right. Questions about what I'm asking you to do?
do I have to do it?
Yes. All right. Everybody's got it? Know what you got to do?